Hey, this is Mr. Warden. I'm doing a video key for Geometry Due Now 19.1, which is week 19, day 1. And first question says, what do we need to draw to do this proof? Well, it says given an isosceles triangle with a median to the base. So that's what we need to draw. We need to draw that given. So here I'll draw it. There's an isosceles triangle. I'm using the same color to indicate that these sides are congruent. I'll also give them a tick mark. And then there is a base, okay, and it would be useful to label these. I'll call that A, and that will be B, and that will be C. And then it says with a median to the base. So the median, we'll use this color here. Actually, I should use a different color than that because it looks too close to what the base is. So let me use a different color. I'll use magenta. There is a median to the base. And, this is not a perfect drawing. I'm fixing it here and there. I might not have gotten the colors exactly right, but that's okay. So I've got a median to the base, and what does it mean that there's a median? Well, it means that this is divided into two congruent parts, and so that's an important component of it. And let's go ahead and give this a point a name as well. We'll call that D. So I should probably use a different number of tick marks for these since I used one tick mark up there. So there you have an isosceles triangle. All right, I'm going to stop there. So what we need to do is draw given an isosceles triangle with a median drawn to its base. And the base of an isosceles triangle is, of course, the side that is not the congruent ones. Okay. 1B, what can we immediately conclude from the drawing that you have to make? Select all 5 that apply. Wow, all 5 is one word. Hint, do the drawing on paper and see what is revealed. So I've done the drawing on the computer screen, and there are things that are revealed. Well, it's a right triangle. Well, no, it is an isosceles triangle. We don't know if it's a right triangle. It could be, but we don't know. All sides have different measure. Well, if it's an isosceles triangle, that's not true. 2 sides are congruent. That's definitely true in an isosceles triangle. All 3 sides are congruent. That is sometimes true if the isosceles triangle is equilateral. The base angles are congruent. That is true in an isosceles triangle. The angles that are opposite the congruent sides. The base is trisected into 3 congruent segments. Well, we are not trisecting the base, so nope. The base is bisected into 2 congruent segments. The base is divided into unequal segments. Well, the definition of a median tells us it's bisected into 2 congruent parts. And then the median is congruent to itself. Okay, that is true by the reflexive property. So those are all things we can really quickly conclude from the drawing. And that will give us a lot of information. We can actually add some stuff to the drawing based on that. I'm going to add that this angle is congruent to this angle. Okay, so that, and we can even add that this is congruent to itself. Okay, so now we have a whole lot of information. We know side, angle, we know angle, side, we know side, and we know this side too. So we could prove side, angle, side, or we could prove side, side, side to prove that these 2 triangles are congruent, which will lead us to where we need to get to. Okay. Now, just to draw that to a conclusion, since we can prove side, 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 and side, 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 then we can prove the triangles are congruent by side, side, side. And then these 2 angles here are going to be congruent by kappa kappa. So I'll go ahead and tie that up with a bow. So these are congruent angles. And you may conclude also that since they are congruent angles and they are supplementary angles, they have to add up to 180, and two things that are the same that add up to 180 have to be 90 degrees. So they're also right angles. Okay, I'm going to move on to Theorem 21, which is exactly what we were just dealing with. Theorem 21, if two lines or rays intersect to form congruent adjacent angles, then the lines are perpendicular. So here's line P and here's line 1. We need to prove Theorem 21. This is Theorem 21, and theorems need to be proven. So we're given angle 1 is congruent to angle 2. And we need to prove that M is perpendicular to P. Well, we have the given, which is that angle 1 is congruent to angle 2. Okay, and assumed from diagram, we can say that P is a straight angle, makes a straight angle. Okay, so angle 1 and angle 2 are supplementary. Okay, so angle 1 plus angle 2 are the measures of them, I should say. Measures of them add up. There's a lot of ways we could do this, but the measures of them add up to 180. And then I can substitute either one for the other one. So measure of angle 1 plus measure of angle 1 also equals 180. Substitution. So I just substituted angle 1 for angle 2 since they're the same. So I'm going to substitution. Okay, and then that means that 2 times measure of angle 1 equals 180, and measure of angle 1 equals 90. Okay, and so measure of angle 1 and measure of angle 2 are both 90 degrees by algebra. Okay, so M is perp to P by definition of perpendicular. 90-degree angle. Okay, there you go. That's basically how you prove it. You might have a faster, shorter way to prove it, but that is the basic stuff. So now we've got this diagram, and we need to figure out what are the reasons for statements 5 and 6. So statements 5 and 6. We have givens. We know that AB is congruent to AC. We know BD is congruent to CD. Okay. There you go. BD is congruent to CD. We want to prove that AD is an altitude. Okay. So those two things were given. We can then say AD is congruent to itself, and that's stated as well as a given. So that is congruent to itself. And so we can then prove that the two triangles on the side are congruent by side, side, side. Now it says ADB is congruent to ADC. Well, we've got kappa at that point. So I'll go ahead and write that in there. Okay, so CP, I'm not going to do it that way. It takes too long to type, to handwrite. I'm just going to type in the answer. So number 6, number 5, I'm sorry, kappa, because we've proven the triangles are congruent. Corresponding parts of congruent triangles are congruent. And then AD is perpendicular to BC. Well, that's Theorem 21 up here. That's the adjacent angles theorem. So we can say 6 is the adjacent angles theorem, or theorem, which you could summarize here. So if two adjacent angles are congruent, then they make a right angle. Okay, or the lines that make them are perpendicular. Okay, and it's useful to go up and review the language of the theorem. If two lines or rays or segments intersect to form congruent adjacent angles, then the lines are perpendicular, which is probably a more elegant way to say it than I did. Okay, so useful to use that. And then we're done with the content, and you're just going to let me know how you're sharing your proofs with me. And I'm hoping folks are moving into chapter 4 at this point. And let me know what you need from me today. Don't forget to hit submit at the end of your do now. That's super important.